Hello guys, I'm a teacher in Bokan Sedrigo Masame. Let us proceed with our sessions for the relativity between two moving objects. Now when these two objects are moving in opposite directions. As usual, we must have two sets of axes for the frame of reference. The first frame of reference is for stationary observer, who record the motions as the absolute velocity for both a walking man and the moving bus. Okay, and another frame of reference is one who is recording the motions of the other. The one who records the motion of the other here is a walking man. That's why we assume the set of axes direct straight to these positions. That is, he's got the same positions. And then this is a set of axes O dash who records the motions of the bus as moving towards the right of the stationary observer O. Now, this walking man will see the motion of the bus as is very far from him as he is walking towards the left. We assume that the one who is moving opposite to the others is the walking man. The walking man is moving towards the left, while the bus is continuing with the same directions as from the previous sessions. Okay, this one observing the velocity of the bus as it is very big and moving very far from him, and hence we will have three projected vector. The first vector is from O B as a vector for the one who records the motions, and the second vector is O to A as a vector for a moving bus, and the other vector is O dash to C. We must rearrange these vectors in such a way that they must obey the vector addition rule. The vector addition rules, you add two vectors in order to get the resultant vector. Hence, we must identify clearly according to the rules that guides us to draw the vectors diagrams. This rule says that when you project a first vector, then the second vector must be drawn from the head of the first vector according to its magnitude and directions. And the last vector must be drawn from the tail of the first vector to the head of the last vector according to its magnitude and directions. The first vector is toward left as OB. This is first vector. And second vector is drawn from the head of the first vector as O dash to C, which is towards the right. And the resultant vector now is drawn from the first vector, which is OB. The resultant vector is drawn from the tail of the first vector towards the head of the last vector, which is vector O-C. Hence, we will have these additions as you can see below. The velocity of man with respect to the ground is a first vector. Then we add the velocity of a bus with respect to man as vector O dash to C, as you see here. Then is equal to the resultant vector, which is the velocity of bus with respect to the ground, that is velocity Bg, as you can see here. Then this when we make the subject the velocity of bus relative to man as recorded by this moving observer, the walking man, will be always equal to positive, because when we take this we justify this by considering the displacement. Then the displacement for velocity of bus with respect to the ground is our second displacement, which is we take the final position we minus with initial position. Okay, our final positions is OA, while our initial positions is OB. Then when we minus, we know that the displacement OB is always at a left of the origins. It is always negative. That's why I put here negative signs. Then the displacement OA is always positive. Then when and is always bigger, because the velocity of bus is bigger than velocity of working man. Then when we divide it with time, the time that is spent by this observer, that is moving observer, the working man, is from A to B, whatever it is from O dash to C, so whatever to A to B, the time will be the same, and always the resultant will be positive values. Thank you for watching. Please like, share, comment. Don't forget to subscribe for more videos like this one.